Section 5.3 will deal with solving by using your square root function. So we need to review a few rules about square roots. First of all, to square root something, it means it's the inverse, the opposite of squaring something. It means it is the factor that multiplies by itself that will equal your given square. We use the radical symbol as the symbol for square root. Here's our radical symbol. The square root of 36 is 6. If I want the negative square root of 36, that means I want the opposite of it, which is negative 6. If I want both the positive and negative, I will put positive negative in front of the radical side, and I get positive 36. The actual number we're finding the square root of is called a radicand, and in this case, the radicand is 36. When we deal with radicals, we have 3 no rules. The first one is there can be no perfect square under the radical sign. As in this previous case, 36 is a perfect square. It could not stay under the radical sign. Second, we can have no fraction under the radical sign. We must simplify that out. And the third no, we can have no radical in the denominator. Radicals can only remain in the numerator. Whatever is under the radical sign can be simplified, and what is outside the radical sign can be simplified. In other words, if I have 6 square roots of 2 times the square root of 2, the 6 is outside and the 2's are both inside, so I can simplify it by taking inside together and outside together. And square root 2 is actually 4, the square root of 4 is 2, so this would actually be 6 times 2, 12. And we'll do quite a few more examples here on the next page of these no rules and making sure what's outside gets put together and what's inside gets put together. All right, let's take one at a time here. First, let's deal with the square root of 500. The directions say to simplify, so you know that is not simplified. So we're going to break it down into its factors. And when I see 2 zeros, I automatically know there is 100 in there. So 100 times 5. Is either of those a perfect square? 100 is. So I can cross out 100, and if square root is 10, does 5 have a square root? No, so it stays under the radical. So this is 10 square roots of 5. Part B is showing you that last rule. What is outside stays outside, what is inside goes inside. So 3 square roots of 12 times the square root of 6. We are going to write as 3 and make one big square root of 12 times 6. This 12 factors further into 2 times 6, plus I have this 6. Now, if there are 2 of the same roots underneath, that means I have a perfect square there and can pull one root out. So I would pull out the 6. And I would have 18 square roots of 2. Here is no fraction under the radical. So I would split this into a radical of the numerator over a radical of the denominator. So this becomes the square root of 25 over the square root of 3. The square root of 25 is 5 divided by the square root of 3. Can you have a radical in the denominator? You're right, you cannot. So to simplify that, you must multiply by the radical of the denominator in the numerator as well. What you do the denominator, you must do the numerator. And that gives me 5 square roots of 3. 5 square roots of 3 over square root of 3. Square root of 3 would be 3. And I have 5 square roots of 3 over 3. Let's try another one. Square root of 2 11ths. Again, I have to break that into the square root of 2 over the square root of 11. So the square root of 2 simplify. No. Does the square root of 11 simplify? No. So we must not have a radical in the denominator. So we must multiply by that radical of the denominator. And I get square root 22 over 11. If the 11 and 22 do not simplify because the 11 is outside of the radical and the 22 is inside. One last one here. I have fractions in radicals again, but I have 2 radicals. So I could write it as one big radical. 2 fifths times 15/8. And in a fraction, anything from numerator to denominator will reduce. So 2 goes into 2 once, 2 goes into 8 4, 5 into 5 once, 5 into 15 3. So this simplifies to the square root of 3/4, which is the square root of 3 over the square root of 4. Does the square root of 3 simplify? No. Can you have a square root in the numerator? Yes. So square root of 3 in the numerator. Does the square root of 4 simplify? Yes, to 2. So I have square root of 3 over 2. And again, in order to use the square root, you must get your square all along. So in this equation, 3 minus 5x squared equals -9. First we're going to subtract 3. -5x squared equals -12. Divide by -5. X squared equals 12 fifths. Now my square is along. So now I will square root both sides. So this becomes x equals plus or minus. And I have a fraction, so I can split it. Square root 12 over square root 5, which is this fractionation, 3 times 4. So it is 2 square root 3 over square root 5, plus or minus, which is, multiply the top and bottom by square root 5, plus or minus 2 square root of 15 all over 5. You get 2 roots. Yes, I have a positive 2 square root of 15 over 5 and a negative 2 square root of 15 over 5. Notice I've been synonymously saying roots. Notice here, it says the purpose of solving is to find the roots, which is the same as the x-intercepts, which means that it crosses the x-axis, which is the same as saying the zeros of the equations, which is why we have set our equation equal to 0. That means when y is 0, I have an x value. So let's continue solving for these roots, these x-intercepts, or these zeros. In this problem, we would add 6 to both sides. 4x squared equals 48. Now we would divide by 4. X squared equals 12. Now we can square root both sides. So x equals plus and minus. And square root of 12 we simplify over here to be 2 square roots of 3. Still got 2 roots. A parabola should always have 2 roots. 2 x-intercepts, 2 zeros. Now let's try 3 times 20 x minus 2 squared plus 4 equals 52. First we would subtract the 4. 3 times x minus 2 squared equals 48. Then we want the square alone, so I must divide by the 3. X minus 2 squared equals 16. Now I can square root. X minus 2 equals plus or minus 4. I don't want what x minus 2 is, I want what x is. So I add 2 to both sides. So this results in x equals 2 plus or minus 4. That is 2 plus 4 or 2 minus 4. 6 or negative 2. Still got 2 roots. Now let's try negative 5x squared plus 2 equals 12. First, we would subtract the 2. Negative 5x squared equals 10. Divide by the negative 5. X squared equals negative 2. Square root. X equals plus or minus the square root of a negative 2. What times itself gives you a negative number? It doesn't exist. So this is no real solution. All right. When an object drops, it drops at the speed of h, the height, will equal negative 16 times time squared plus the initial height. So the tallest building in the United States is in Chicago, and it is 1,450 feet tall. How long will it take a penny to drop from the top of this building? Well, my initial height is 0, and I want my height to be 1450. So that would be 1450. Excuse me. My initial height is 1450 because I'm on the top of the building dropping. So I have h equals negative 16t squared plus 1450. And I want to know how long it will take to drop it. So that means when it hits the ground. So my h distance is 0. Or I am finding my zeros. So in this case, this would act as y. So this would be 0 equals negative 16t squared plus 1450. Subtract 1450. Negative 1450 equals negative 16t squared. Divide by negative 16. T squared equals, and then, let's see, what is negative 1450 divided by negative 16? 90.625. Then I'll need to square root that. That means T is approximately 9.5 seconds. So in 9.5 seconds, that penny will hit the ground. Part B says, how fast will the penny be traveling when it hits the ground if the speed is given by S equals 32t, where t is the number of seconds since the penny was dropped. So S equals 32 times my time, 9.5, which is 304 approximately, because my time was approximated, 304 feet per second. All right, and here's some of the square roots for you to practice as well.